Hi, everyone. This is the last lesson, so lesson 4. Oh, they're not going to be happy. They wanted me to keep this whale. You won't know who they is. But don't confound your compounds. Solving and graphing compound inequalities. So this is what we're going to learn. This is our last lesson for before the test. Okay, right, whale? Yes, right. Okay, so we're going to be on page M2-117 right here. So this is our warm-up. Again, our learning targets is write simple and compound inequalities, graph compound inequalities, which is, the do now, and then solve compound inequalities. We're going to spend most of our time here trying to solve these things. All right, so here, if you remember, x is greater than or equal to -6. So literally you go to -6, right? -6, and then it says greater than, so we're going to go to the right because all those numbers are bigger than it, right? And then if we look at number 2, we're at 7, and 7 is less, it says x is less than 7, so anything that's less than 7 works, is a solution, right? So like 6, 5, 4, negative numbers and all that kind of stuff. We just can't equal it, it just won't be 7, right? Because it can't equal 7, it just has to be less than 7. That's why this is an open circle. So again, anytime we have an open circle, we're looking for like either a less than or a greater than symbol, right? And if it's a closed circle, that's going to be less than or equal to or greater than or equal to. It's the one that has the equal to sign underneath, right? So again, this is open, right? Do you see how the O is open and then it closed? Okay, there's nothing fancy about that one, just closed. Yes, we should just close this one right there. There we go, closed now. All right, so open circle and closed circle. Okay, so and if you see this last one right here, notice that there are 2, right? 2, 1 on each side. So basically we're saying that x is between -5 and 4. So anytime you see like between or something like that, like an interval of some sort, that's a type of compound inequality. So we're saying that x is bigger than -5 or equal to, but less than 4, right? So notice that they're both the less than symbol like this, right? Almost always going to be this way. Just in general, we normally write the smallest number first, and then we write the bigger number. In this book, they'll show you other ways just so that you can see them, but normally that doesn't happen. So same thing like this, if I ask you, who are teenagers? What are the ages that are considered to be a teenager, right? You say, oh, from 13 to 19. Or you can say from 13 less than or equal to x, which is less than 20. So notice that it doesn't equal 20, it is just less than 20, right? So 19 would work in that. 19 and a half, you're still 19, right? So you're still a teenager until you hit 20, because boom, right when you hit 20, you're no longer a teenager, right? Sad days for you. All right, so that's so this is the same thing, right? So this is what we call a compound inequality. We just are having say between these 2 numbers, or there's another way, but I'll show you. So we're going to skip this page right here. We're going to go right into, this is page 119. So on your book, you're on 119, right? You're like doing this with me. I'm not just doing it by myself because that's sad days, right? So these are some shipping fees for a particular website called goodsportsbuys.com. I don't know if that's a real thing, but I'm going to say probably not. But this is how they determine their shipping fee. It depends on how much it costs, right? So it's if anything from a penny on up, including $20, right? That's going to be a shipping fee of $6.50. What does that mean when we write that as an inequality? So it's anything from a penny, so 0.01, and then less than or equal to whatever the cost of this item is, right? And then $20. So it's including 20, so that we have that equal sign there. Okay, so far so good. Whale, did you get it? Are you understanding that? Yep, he understands. All right, and then so we're going to do the next one here. And if you notice that we have, it says more than 20. So more than 20, so it's more than 20 here. That's our smaller number, right? And we have 50 on the other side. And it says up to and including 50, right? So it has to be greater than 20. And then it can also equal 50. So that's where we have the equal sign right there. See how that goes? I try to color coordinate them. See? So there we go. And then here, the next one's between 50 and 75. It says it's between it, but not equal to, right? So it's literally 50, 75, in between. See how C is literally in between it? Actually, should I do it this way? Does that make more sense to you? So there we go. So that's in between. And that would, the shipping cost would be $11 for those ones. And here it says from 75 up to, but not including 100. So like $99.99. That would be one. So it says from 75, so it equals up to 100, but it does not include 100. So anything less than 100. So if you look right here, that's why it does not have the equal sign. Okay. And then for the last one, it says 100 or more dollars. Anything above that is just going to be $13.10 for the shipping fee. So hopefully they don't have things like $1,000, right? So here we have C is greater than or equal to 100. Notice this is only just one inequality. There is no in between. There's just one number there. So we are just like C is greater than or equal to 100. Okay. Here we normally have the C on the left-hand side. So this one can be greater than or less than. All of these here are less than. That's just standard practice. Okay. Usually we don't have them do things like this or like this. We can't do that. Okay. I am not throwing up any kind of signs. Just we don't do the inequalities this way and we don't have them this way. They either follow this way or this way. Got it? All right. Oh my dear. My wrist hurts now. Okay, so we're gonna just go on to the next part here. So if you take a look, we're on page, yes, 123. So 4.3 activity, 4.3. Are you there? Flip. Okay, so these are the solutions to a compound inequality. So a compound meaning where we have two numbers, right? The X is between these numbers, or it's like less than this number and greater than this number, things like this, right? So if you notice right here, this is going to be, notice it's going to be A is less than X, which is less than B, right? So basically we're saying that A or that X is in between A and B. Here's A, here's B, in between that. So this is like Arduino, right? So this is what we call a conjunction. If you notice, I kind of drew the arrow there. That's a conjunction. Like remember, C-O-N is with, right? So it's with junction, like jungle junction. It's where all the jungle people meet. Just kidding. So it's so they're together, right? So remember, so now disjunction is like, nope, they're not together anymore. They got into a fight. They're disjointed, right? So it's called disjunction here. Okay, so this one you'll normally see an or here. So here it is our and, like it's bigger than A, but less than B, right? It's doing both of these things, right? Here it's an or, it's either X is less than A or it's greater than B. Okay, so here's X is less than A or it's greater than B. So notice it does this thing, right? They're not together, they are separate, right? So it's either the one on the left or the one on the right. You know, right? So that's how those look. Okay. Sometimes we'll get things that look like this, not often, right? Which means that do we really need this one? Not really. It's just that. All right. So we're going to go to this next. So, oh, this is what I was talking about, right? So it is going to be, notice right here, it says X is less than -2. So we have that line going there to the left, and X is greater than 1 going to the right. Notice this is like the no-fly zone. Nobody's in, there's no solutions in here, right? So either you pick a number over here on the left or a number on the right. You can't choose one that fits both. It's not possible, right? And here we go. We're on bottom of page 124. And it says we're going to be writing this solution or drawing the solution down here. That's literally what we did. So really, I would take the time, try to do these yourselves. If you were not in class or you were like falling asleep, right? You're like falling asleep, you're not dead, that's sleeping. Then you would want to make sure that you do these, please. All right, so notice again, 2 and 3. So X is less, so we have an open circle at 2 because there's no equal sign below. And it says X is less than, so we go to the left. Here it says X is greater than 3, so we're going 3 to the right. I always like to use those little, like I put a little up and then go to the right just to show, because if I do it on the number line, it's kind of hard to see where it's going, especially if it's on a like a worksheet or something like that or in a book. So I always do it this way. All right, and so some more here. And if you notice right here, it says this was a minus here. I just changed it to a plus because it was -1 is greater than or equal to x, which is greater than or equal to -1, which means that your only point would just be at -1. That's it. And so I just made that into a plus. Okay, so you might want to take note of that. And if you notice, these are greater than or equal to. We don't normally do this, but like I told you in this book, they like to show you different things that you don't normally see. Okay, so here 1 is greater than or equal to x, which is greater than or equal to -1, right? So which means it's between 1 and -1, just like that, okay, in between. So then let's try to take a look at this one. It says x is less than 0. So we have it 0 going to the left, or x is less than 2. So do you see what I'm saying? Do we need this one? This is kind of unnecessary. This is like don't really need this. It's kind of like moot point here. Because if it is less than 2, then it's definitely less than 0. So we're good to, and it says or, so it doesn't even have to fit both. It just has to be one or the other. So it just, So yeah, you usually, again, that's why you usually don't see ones that are like this, because they're kind of redundant, unnecessary. But that's what that would look like, just saying. And then if you look at D, D is going to be greater, x is greater than 1. So we're over here at 1, open circle, because there's no equal sign. It's going to the right. And x is less than -2, so here's at 2. So again, this is a disjunction. Oh, it says and. Ooh, can we do this as an and? We can't actually, because it can't be both this and this at the same time. So let me just change that to an or, right? Hope you guys knew that, notice that, right? And another way to write the, the conjunctions, the way like how they did for B, is to write them as two separate ones. We just say and, right? So it's x is less than 3, right? Right here, x is less than 3, and x is greater than 2. And so it has to fill those two things. It has to. So goes to the right. So we know that's somewhere in between 2 and 3, like 2.3, 2.5, 2.7, 2.99999. Anything in between 2 and 3. It just can't be 2 or it can't be 3. All right. And here we go. So let's try this one. So it has to be both less than 2 and less than -1. If it's less than 2 and less than -1, basically it can't be in here. It can't be 1 because it's not both of them, right? Because it has to fill both. So it basically is just going to be this one right here, because what it has to be both less than 2 and less than -1, which means that it has to be definitely less than -1. Because if it's like at 0, that's less than 2, but it's not less than -1. So it wouldn't work. So it's just basically it just has to be this one. X is less than -1. That's what it has to be. My last one right here is, what do we have? X is greater than -1 or X is less than 0, right? And if you notice right here, there's no or, it's just an and at that point, right? So we would write it like this. Okie dokes. All right, so now we're going to go into the next section right here, which is solving inequalities in compact form. So basically that looks like this. So I just took this this worked example and we just did it here on the left hand side. If you notice right here that we have basically like two inequalities, right? So instead of having two sides, we actually have three sides. Three, I know. And so I put this little highlighter going down just to show you that, yes, these are the separate sides. So you can visually see what that is, okay? So we're gonna solve for X the way we normally solve for X. Gotta get rid of that 7 first. So we're gonna subtract 7. But instead of subtracting 7 on two sides, we actually have three sides to keep equivalent, right? So we're gonna subtract 7 here, and 7 here, right? Do you see the 3 7s? And then once you do that, -3 minus 7 is -10. And we got the 2x, and then 11 minus 7, which is 4, right? And then, so from here, we just want to get rid of that 2. So we just divide by 2 on all three sides. It has to be all three sides, or else one of the sides is not going to be equivalent to what it was before, okay? Like the same kind of, I guess, proportion. I don't know how you call it, but you know what I mean. So here we've got -10 divided by 2, which is -5. 2 divided by 2, which is 1. So that's just right there. and 4 divided by 2, which is 2. Question is, do I need to change the signs? Didn't we have a negative in there? And I hope you said, no, we don't, Miss Lee, because did we divide by a negative? No, we divided by a positive. So we're good. So even though the negative 10 is negative, that has no bearing on whether we switch it or not, because the action that we did was not negative. Okay, we did not divide by a negative number. So therefore, this is fine. So this is our answer right here. So -5 is less than or equal to x, which is less than x, less than 2, right? And if you notice right here, that's exactly what we do. So remember, there's a closed circle at -5 because it says equals. We have an open circle at 2 because there's no equal sign, right? So we're going to do some practice. And if you notice right here, we did lots of practice. So we're on page 126. So please, if you have not already, please press pause. Do the problems, all right? So let's try these out. I'm assuming you've done them now and you've done as far as you can. If you're lost, then, you know, you just be like, well, let's do this together. All right, so again, notice inside for the x, we have this -6. We're just going to add 6 to all 3 sides. So then these are going to cancel out and all I have left is x. So now the 6 plus 6, that is now 12. And 9 plus 6 is 15, right? So our final answer is 12 is less than x, which is less than or equal to 15. And this is what it will look like on our graph. All right. And same thing with, I don't know why there's that random line there. So notice we have a negative here, right? So if we have a negative here, can't have that. So we're going to divide all 3 sides by -1. You could also multiply by -1 on all 3 sides. That's fine. Either way is okay. But here we just decide to divide. And notice this is now going to be positive. That's going to be 2, and that's going to be -6. Now remember, we divided by a negative number. So now what was this way is now this way, right? What was less than is now greater than. So we are changed. So as 2 is greater than x, which is greater than -6, which means that -6 is our smallest number, right? And then we got over to 2, and it's anything in between that. Okay, because could you imagine if we did not flip them, then we would say 2 is less than x, which is less than -6. That doesn't make any sense. It's like saying that your mom is younger than your older brother, who is younger than you. What? Right? Do you see how that doesn't make any sense? So yeah, we can't say that negative numbers would be bigger than the positive numbers. So that's why we flip them. All right, so here we have letter C. We have a few more things to do here. So we're going to subtract 1 on all 3 sides. And then we get, so our 1's cancel out. So we just get -4 minus 1 is -5, is less than or equal to -3x, which is less than or equal to 11. And then from here, we're just going to divide by, we're dividing by a negative number. So notice right here, we did switch them. So they are now switched to the other way, right? So this is going to be 5 over 3, x, and this is -11 over 3. And notice I just wrote these as regular like mixed numbers because I have to graph that. And I don't know how to like plot 11 over 3. So here we go. This is going to be -2/3 or 3 2/3. So we're over here at -3 2/3. This is 1 2/3. So we're over here in between the 1 and the 2, but a little closer to the 2 since 2/3 is more than half, right? So there we go. And we're just like that. So now, well, this is towards the end of the class and we did not get to E and F. So I will do E and F. So if you look at these, now we have this OR, right? So literally it's just, we're just doing 2 different problems. And then at the end, we're just going to connect them with an OR. That's all. So here on the left-hand side, let's just solve for x. So we're going to, since it's adding 7, subtract 7. So we get 2x is less than 3. And then we're going to get rid of that 2. So we're going to divide it by 2. So x is less than 3 over 2. All right. On the right-hand side, we have -x plus 7 is greater than 10. So we're going to subtract 7 on both sides. And then we got -2x is greater than 3. So now divide by -2 because, you know, -2 is multiplying. They're not adding. Do you see an adding in there? No. That means that they're multiplying. So we're dividing both sides by -2. Remember when we do that, we remember to flip the inequality. Okay. So now that's going to be -3/2. So we did not graph this in class. So let's do that right now. So 3/2, this is like 1.5 or 1.5. This is -1.5, right? Or -1.5. So here's 0, here's 1, here's 2, and -1, and -2. So 1.5 is about right here. And that's not, it's an open circle because it's not equal to. It says less than, so we're gonna go less than. And then here, it is x is less than -1.5. They're going in the same direction. Like this is, yeah. So do we need this one on the left? Unnecessary, right? Because if it fulfills the one on the left, or one on the right over here, it's got them all. So yeah, because it's an or, so either or. So when that happens, you can just take the one on the right, and you technically don't need, but this one is unnecessary. Just on the right. So let's try this one. This was another or. Okay, and so I notice right here I have this +3. So I'm going to just subtract 3 on both sides. And I get 1/2 x is greater than 1. And I got to get rid of this 1/2. So I'm going to multiply by 2. The reason why I multiply by 2, because it's technically 2 over 1, but what's 2 over 1? 2. So that's why I just do 2. If you want to write over 1, you totally can do that. So all I have left on the left-hand side is this x is greater than 2. Right? Now we're going to do the one on the right. Let me do that in green. Oh, no, blue. So here I have a negative x. I want to get rid of the negative x, so I'm going, or just the negative, not the x. We're just going to divide by -1. All right, and then I'm going to have x, remember we've got to flip it, is greater than -3. So the way I write this is x is greater than 2, or x is greater than -3. Right, and then the way that was going to look that, this is going to be, here's 0, here's 2, here's -3. Okay, this is my lazy way of doing it. All right, again, it's going to be x is greater than, so it's going to be like this, or it's going to be greater than 2. So honestly, do we need the one on the right? Because we're like, if the x is greater than -3 is going to cover everything, so we don't technically need it. So it's just going to be x is greater than -3. But yes, this would be what we're looking for. All right, last one here. Notice, okay, so there's my or right here. So I'm expecting some kind of or, right? Again, we're going to just subtract 1 on both sides. Ooh, the colors look about the same. We have 6x is greater than 10. And we're going to divide by 6 on both sides. And then we get x is greater than 10 over 6. Okay, which we know is like 1 4/6, or 1 2/3, right? And then let's try the next one. So this is going to be +4 + 4. So we get x is less than -1. All right, so let's try this out. Oh, we didn't write the end. So x is greater than 10 over 6, or x is less than -1. That would be our answer, just like that. Now let me just take you down. Oh. A little bit lower because that's just way too high. And here we go. So here is 0. Here's a -1. And this is 1 and so 1, 2. So 1, 2. So, oh, that spacing is a little off, but sorry. So here's that -1. So it says x is less than -1. So there we go, less than -1. Or remember 10 over 6 is 1 4/6. So it's going to be closer to the, that's an open circle, by the way. And it's going to look like this. Okay. Or, all right. So I hope that was helpful to you. And watch the parts that you need to watch again if you need to. And I will see you later. Bye. Whale say bye. Bye.